section 10.2 of Math 8, where now we're going to model and solve two-step equations. We did one last time, now we do two. Remember how we did that modeling too with those algebra tiles? Here we go. Let's draw it one more time. A positive variable is represented by a solid rod. And then a positive number represented by a solid little square. A negative variable is represented by a hollow or unshaded rod. And the -1, of course, is once again a unshaded square. So let's take a look at these type of equations now. Our first example says 3x plus 2 equals to 14. Once again, I'll show you the method by modeling with algebra tiles, and then we'll do something called opposite operation, or what people call algebra. So 3x, there's your 3 rods, plus 2, your 2 squares, and this equals to 14, and I've drawn 14 on the right-hand side. Once again, the goal here is to figure out what value must one positive variable have. So the goal is once again to just have a positive variable on the left side. Well, that just means now I have to remove some stuff. How about removing these 2 red squares? And remember, whatever I do to the one side, I must do to the other side. And so if I do that, what I have now as my new picture is I've got my 1 rod, 2 rods, 3 rods, so I still have my 3 rods on the left side. But now on the right hand side, look how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, doesn't this kind of look familiar? In the previous section, we were given questions like this. In this diagram, I have now 3x is equivalent to 12. Well, how do I solve for one of these x's? We did some grouping. So here's one group, here's another group, here's a third group. And then to solve for x, we're just going to focus on one particular group. And what does it show me? It shows me that we have here x, or 1x, is equal to 4. Done. Now, by the way, we can also check our answer. So we can check by plugging in our value of x into the original equation. So remember, our original equation is 3 times x, or 3 times 4, plus 2. 3 times 4 is 12. 12 plus 2 is 14. And that equals to the right-hand side, so yeah, we know we're right. Now, once again, if you don't like algebra tiles, or you just think, oh, drawing pictures is too long, well, let's see if we can actually do the same question with opposite operation. Now, with opposite operation, you're going to ask yourself, what is the opposite of doing what it said? 3x means multiplying by 3, and then plus 2 means adding 2. So what's the opposite of multiplying by 3 and adding 2? Well, we have to go backwards, so we'll have to reverse the adding 2. Probably then we're going to be subtracting 2. And then the opposite of the opposite of multiplying by 3, I gave you the answer, is dividing by 3. Okay? Now let's see how this works. Okay? So let me ask you to copy out the original question again. 3x plus 2 equals to 14. So our goal here is to solve for x, or isolate x. And just like before, we had to take away the 2, and that's what I'm going to do now. So that's the subtracting of 2. So doing that, we now have 3x. The positive 2 minus 2 is 0, and 14 minus 2 must equal to 12. And then now 3 times a number equals to 12. How do I find out what that number is? Well, the opposite operation of multiplying is dividing. So we'll divide both sides by 3. And I hope we'll get our answer. And I think we actually do. X equals 2, and 12 divided by 3 is 4. Same thing. Okay? And that's how you do this. So Example number 2, same kind of idea. I'd like to see if you can actually do this yourself. So I'm going to kind of ask you to pause the video and try on your own first. If you're stuck, then come and start playing the video again, and I'll be working on it here. But the goal here is to see if you can try it yourself first, because if you can do it without me, that's awesome. Algebra tiles. How do we show 2x? That's 2 positive rods that are shaded in. Minus 3 is 3 unshaded squares. This equals to 9. I better draw a whole bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Our goal here is to remove 3 negatives. So I will take them away. Bye-bye. And wait. There's nothing on the right-hand side. Uh-oh. Like my daughter says. So what do? We must add in our, yes, 0 pairs. How many 0 pairs do you think we need? If you said 3, because I want to remove 3 of those negative ones. So goodbye. Okay. And so now our updated picture looks like what? Well, I'll draw it for you. 2 rods. And we have, I believe, 12. And I'm going to draw 12 strategically because I want to try to group them. So 1, 2, 3, 4. And by the way, I'm doing this because I see 2 rods only, right? So 2 in each kind of column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's do a group. And in one of these groups, we'll see here X. And then I see 6. And ta-da! Once again, let's try with opposite operation in algebra. You'll need to know both ways. Okay. So what's the opposite of multiplying by 2 and then subtracting negative 3? Well, let's find out. I will once again copy the question down. What you want to do now is isolate the x, or have the x's by itself. So what's the opposite of subtracting 3? Oops, by the way, here, this should be just a 3, not subtracting negative 3. My fault. Change it, please. So what's the opposite of subtracting? What am I doing? You're right. Oh no, I'm wrong. Yeah, subtracting 3. So what's the opposite of subtracting 3? It's adding 3. So we do that, and we're given 2x's equals to 12. By the way, do you see how the algebra actually matches with my picture to the left here? Yeah, I hope you can see that, everybody. So, oops, I just pressed something. Hope it turns back. Okay, so anyways, we have 2x equals to 12. How do I now do the opposite of multiplying by 2? You guessed it, divide by 2. And so now our answer is x equals to 6, just like with the tiles. All right, we've got one more to try on the back. So I'm going to ask you to turn the page now. And now we've got example number 3, where we're asked to solve this particular question. Negative 4x, take away 5 equals to 7. And yes, I want you to do it again by both methods, algebra tiles and opposite operation. Okay? Tiles first. Negative 4x, draw that out. Minus 5, draw that out on the left side. This equals to positive 7, draw that out. 1, 2, 3, 4, 5, 6, 7. And then our goal here is to get rid of the 5 negatives from the left side, which means we need to get rid of 5 negatives from the right side. We don't have 5 negatives from the right side. Hello, zero pair. Once again, how many do we need? I gotta get rid of 5 of them, so how about 5 zero pairs? Bye-bye! And then once you got rid of them, we can redraw our picture and group them nicely. So 4 negatives, and I believe now there are 12 positives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay! Group them together, and what do you see in one of the groups? I see negative x equals to positive 3. Once again, we are not trying to solve for negative x. You're asking to solve for just x, or the positive variable. So this is where we have to kind of flip it, or just rearrange, I guess. Unshaded becomes shaded. So we're going to have to kind of reverse or flip. So the negative x becomes positive x. So negative becomes positive. So these positive 3 become negative 3. And therefore, we don't have negative x equals to 3, but now we have positive x equals to negative 3. Okay? Once again, we can do this by opposite operation. So let's see if we can do that. What's the opposite of multiplying by negative 4 and subtracting by 5? Well. Time for you to find out. Negative 4x, take away 5, equals 7. Our first step is to try to isolate x, so we got to do the opposite of subtracting 5, which would be plus 5. Doing that, we're left with negative 4x equals to 12. And then here, to do the opposite of multiplying by negative 4, because we have negative 4 times x, the opposite of multiplying will then be to divide. And in this case, let's divide by both sides. Divide both sides by negative 4. And what we have left over, x equals to negative 3. Aha! The same thing as method 1. Okay, so I think I've done enough examples with you. What I'd like you to do next now is try those exercises underneath. I'm going to ask you to try it with either method, but eventually I would like you to use the opposite operation. So if you actually know that quite well, I would strongly suggest that you do A, B, C with that. If you still have some struggles and like the visual picture, then maybe start doing the visuals for maybe A, but gradually for B and C. See if you can transfer over to this opposite operation algebraic method. Alright, so once again, let's pause the tape. You do this, then come back and check if your answers are correct. Go! never did ask you to check, but I think it's good to do so, because with this, you can guarantee that you're always going to be right. Now I do want you to show all these steps as well. So these little numbers like I did here, like -5s and then divide by 2, you gotta show these, they're part of your work, okay? Later on, when you get more comfortable with not showing these, because you know this stuff so well, then that's fine. So in grade 9, maybe you don't need to write those little numbers down, but right now, I want you to do so.